Good morning, everyone, and welcome to the RestoreNet launch webinar. We're going to take a few minutes this morning to walk through what RestoreNet is and how you can get involved and what we hope to accomplish. Our objectives this morning are to get a summary of RestoreNet and its study design across to all of you attendees, to understand the costs, learn how to participate, and help identify sites for the project. Also, we'd love to hear your feedback at the end. The RestoreNet team has put this project together. That group is composed of myself, Tom Kay, Matt Bain from the Institute for Applied Ecology, Peter Dunwitty from the University of Washington, Sarah Hammond from the Center for Natural Lands Management, and John Bacher from the University of Washington. Please welcome all of them as well as everyone here on the phone today. We had a meeting last month, 2 months ago now, in Portland at the Metro office, and our goal was to convene a larger group and really talk through some of the lessons learned, current challenges in grassland restoration, and some study design ideas so that we could synthesize and create our final study design, which we're launching today. So we want to thank that group that participated in that meeting. Brief amount of background. Prairie loss is one of the motivating issues we're facing through RestoreNet. Restoration is clearly necessary to reverse the trend of prairie and grassland habitat loss. But unfortunately, our success rates are highly variable, and we don't often understand why a restoration works or does not work. Habitat loss has resulted in a decline in prairies and grasslands, and with them, diversity. Often species are becoming endangered or at risk. Restoration is really necessary to expand the extent of this habitat regionally and globally. Yet the success rate of restorations is highly variable and poorly understood. On the left is an image of what we might call successful restoration, where the dominance and diversity is natives, whereas on the right, an invasive has just swarmed over the plot, and we would not call that a successful restoration. However, these plots are at the same site and received many similar treatments, so why does it work in some places and not in others? Also, the cost of prairie restoration can be very high. The seeds alone can be very costly. The cost per acre can be hundreds of dollars, ranging up to even $1,000 per acre. When we fail, we lose not only the value of those seeds, but the effort it took to collect and make those seeds available, and we lose time. If we want higher genetic diversity in those seeds, the cost can go up even further. And using threatened and endangered species could even double the cost. And of course, as the pounds per acre increases, the cost per acre goes up. So some lessons we've already learned include that the weed community affects the restoration success. Also, the effect of restoration methods differs between sites and years, and the seeding date matters. Even a month or several weeks apart could change the results of a restoration. Soil conditions affect which species establish and how well they establish. And also, we know that networked experiments can be very efficient and effective and yield broad implications across regional or even global scales. So, at least in terms of the first four factors, can controlling these factors make restoration outcomes predictable or treatments more prescriptive so that we have a better chance of getting it right the first time? So, welcome to RestoreNet. This is a regional and we hope eventually a global prairie or grassland restoration experiment. And we have this sort of corny logo, and the goal behind this logo is to point out that we have questions around restoration. We want to get answers, and we want to make the process of restoration more efficient, both in terms of resources associated with dollars, but other resources as well. And we want to do a replicated experiment to get there. This project is open to participation from anyone. The experimental plots should be placed at planned restorations, although they could be placed in smaller scale restorations if someone wants to take that on just to host a plot. The experimental design is to be standardized across all sites so that we do the same experiment everywhere and improve our replication by having greater participation. The seed mix can be made available, at least in the beginning, for the Pacific Northwest. The plot sampling by participants or a specialized crew, depending on skill level, will be conducted so that we have high quality data capture. We want to have strength in numbers. Even though individual sites may host an experimental block, that block is unreplicated and does not represent a standalone experiment. We need to assemble our results together to be able to make statistical conclusions and inference. The cost per site is up to $2,800, including everything. If you have, for example, if you're in the Pacific Northwest and you want one of the members of our RestoreNet team to come and take on the experimental block for you entirely, that would be the cost. We'll get into that more in a little while. So we have a few driving hypotheses, and they're arranged like this: that native plant establishment and community development in restorations depend on these factors. Restoration techniques that affect seed soil contact and competing vegetation, site factors such as texture, nutrients, the weed seed bank, the weather in the year when seeds were planted, and so on. And finally, the traits of the species used. In other words, some species are different from others. They may be taprooted or rhizomatous, annual or perennial, have rapid growth rates, etc. And we're mixing in with this the seeding rate, the number of seeds that are put on the ground. We'll manipulate that. So getting into the RestoreNet experimental design, there are a number of factors we want to look at. Some of those are site factors, and those are things that we observe and are used to correlate with the native plant establishment and community development. So those sorts of site factors could be factors associated with the soil or the weed seed bank, and also the weather year, the timing of when seed is put down. Those are things we'll handle as observed corollaries with establishment. The experiment, though, will also manipulate some factors. And the factors we want to manipulate are those that we can control. And those are used to test for differences in native plant establishment that are due to the factors we can control. By looking at all of these together, we can ask questions like, do the effects of the treatments depend on site factors? For example, the way we seed, does that affect how well seeds come up at one soil type versus a different soil type, where a different method might work best? So the more we understand about a site, perhaps, the better able we will be to achieve restoration success by dialing in our technique. More specifically, site factors that we want to look at include the soil. We want to look at a complete soil nutrient analysis. I won't walk through all of these, but suffice it to say, we're interested in soil texture, pH, soil chemistry, active carbon, things like that. And the soil on the right, I'm just going to point out, is the state soil of Oregon, the Jory soil. Other soil factors or site factors include the soil seed bank. So there are a lot of weed seeds in the soil. Even after site preparation, many of those seeds are going to be viable and will germinate. We want to be able to understand what comes up in a restoration site based on the soil seed bank, so that we can actually predict what many of the weeds will be and what problems we will have at a site. So we can test the soil for the seeds that are present. And this can serve as a measure of site preparation effectiveness. So site preparation that results in a smaller weed seed bank may be more effective than one that resulted in a very large or intense weed seed bank. And this allows us to examine the question, do seeds in the soil predict weed growth? And do they interact with the seeds we place on the ground to affect the community that develops? Other site factors include the weather and the timing of when we seed. So, every year is a little different. Some years are very hot, some are dry, some are cool, moist. Does the weather during the year of seeding affect the ultimate outcome? And there's considerable evidence to suggest that it does. How about the date of seeding? We're not going to prescribe when seeds are placed on the ground, but we want to know when that date was. So we'll capture that information because we do know that seeding timing, even a few weeks apart, can affect the ultimate result. Manipulated factors. This is really part of our experimental design where we get to control things. So our factors that we're going to look at include the seeding rate, and we'll look at the seeding rate as what we consider a base or a standard, and generally this is around a cumulative total of around 10 pounds per acre. We will also double what we consider the base and triple the base. That's a lot of seeds, but many of us have noticed that when we put native seeds on the ground, that they are vastly outnumbered by the weed seed bank. And that in part may explain differences in success. We also want to look at our seeding method to look at ways that can improve seed soil contact and make a better seed bed. For example, we can broadcast directly onto the ground with no preparation, or we will manipulate the soil surface. We'll scarify it, we'll rake it, and also roll it. We can also use a pre-emergent herbicide, and our approach there is to apply a pre-emergent herbicide several months before seeding so that its half-life, if you will, starts to deteriorate before seeding happens. So in this climate here in the Pacific Northwest, that means spraying in May or June, and then seeding in September, October. And we expect seeds to start germinating anywhere from when the rains come in the fall, usually in November, through February and March. Many or some pre-emergent herbicides will lose their effectiveness over time, and our rationale here is that the early germinators are predominantly the weed species, and the later germinators are predominantly natives, so that if the pre-emergent herbicide is declining in effectiveness, it may still be effective in the fall, but lose its effectiveness by the winter, so that at least some species will be able to come through. And so we'll learn quite a lot from that about what species are sensitive, as well as how timing of the pre-emergent herbicide can be used to leverage its deterioration and improve seedling establishment of the species we want and reduce the weeds we don't want. So our seed bed and weed control treatments are raking and rolling, and also the pre-emergent herbicide will be applied generally with a backpack sprayer and a boom to control the rate. So the experimental design is to have a block at each site, and the block will have a 2x3 factorial design. The first factor is a seed amount. So we have our base seeding rate, or double or triple that. And this will be set in the Pacific Northwest, we're hoping, by the RestoreNet team. So we're all doing it exactly the same way. But globally, if others are interested in participating, then that will depend on the local practices of practitioners. And so the doubling and tripling will be based on whatever the base is in your region. The second factor is the seed soil contact manipulation. That's raking and rolling versus surface broadcasting only. And then the third factor will be a split plot. Although we're revisiting this, we may change this, but the idea is to use a split plot statistical design where each of the other treatment combinations is split in half. Half receives the pre-emergent herbicide treatment, such as imazapyr, applied in May and June. One reason we're looking at the herbicide imazapyr is that it has some formulations that are labeled so that it can be used in aquatic environments, such as habitat is a formulation like that. It's also labeled for use in wildland restoration, so it's available for this on a larger scale. And our seed mix, we're hoping, will contain up to 20 to 30 species across a wide range of plant traits. And we're going to document those traits, and so that we can understand if plant traits are involved in how these individual species respond. And then we can extrapolate to other species with those same plant traits. That's our goal. This is what it would look like on the ground, potentially. The light blue would be the base seeding, in the Pacific Northwest, perhaps about 10 pounds per acre, scaled down to the plot here. The green represents the double the base, and the pink or reddish represents triple the base. So these are all seeding rates. The soil surface preparation, whether it's prepared, raked, and rolled or not, is shown here based on the hatching, the horizontal lines. So if you have those two factors, one at 2 levels and one at 3 levels, and you cross them, then you have 6 possible combinations. So each block will have 6 treatment combinations. But each of those 6 treatment combinations will be split, and half of it will be sprayed with pre-emergent herbicide and the other half will not. So that's how we get all of the treatments combined here. Now, I did mention that we're considering making the split plot actually a full factorial design, in which case we'll have just 12 randomly assigned treatment combinations within each block. But that shouldn't much change our layout or our size. Right here, we're looking at a block that would be 8 meters by 7.5 meters. Or if you wanted to reorient it, it would be 4 meters by 15 meters. So that it can fit in a relatively small area and fit into differently shaped areas. The reddish dots with blue circles around them represent places where we could randomly sample the soil for the seed bank and the soil chemistry samples that we will need to take. This is where we would split. I'm showing it shaded like that. That would be the spraying across a portion of it. Now, I'd like to point out that we could look at a site where restoration is occurring across a broad area and potentially in phases and accommodate more than one block. For example, we could put a block here in what we call phase 1 of this restoration and another block over here in phase 2. They're in different years, there are different soil types. We could even potentially add another block in the same year into a different habitat, like a moist swale versus a higher area. We would expect potentially differences in behavior of the plants we put down in slightly different habitats. So although each block is an unreplicated experiment. If a practitioner wants to try to place blocks in different habitat types or in different overall site prep conditions, that's compatible with what we want to do. So here's another summary of the experimental design. Again, it's a 2x3 factorial experiment with a split plot on herbicide. We're looking at broadcasting versus harrowing and rolling, or raking and rolling. We're looking at 3 different seeding rates and the use of pre-emergent herbicide. We want to take many site measurements. We're interested in soil chemistry and texture. We're interested in the seed bank. We're interested in the weather conditions and the seeding date. The duration of this. The project is designed to have a block installed at a given site in the year that that site is ready for seeding. So the practitioner is already doing restoration there, for example, and the site is being prepared by the restoration practitioner. This experiment starts when that practitioner is ready to seed, or at least in the year they're ready to seed. In the Pacific Northwest, we're looking at an 8-year run, at least for the project. We want to have blocks start in each of 5 weather years. So 5 years in a row, we'd love to have several plots or several blocks start in each year. So we don't want them all to be in the same year. We want to spread this across time so we understand how different weather years affect our outcomes. And then we'll sample these plots for 3 years after they're seeded. And the results will start to accumulate really in 2 years. In terms of sampling, we'll use 1 by 1 meter sample plots. These will be sampled once per year for 3 years. And then we will measure plant cover and possibly seedling establishment if we can work out an efficient sampling scheme for that. Additional points, we expect there to be 1 to 3 blocks at each study site. That could be actually more than that. We're open to whatever folks want to do. The experimental design will be a randomized complete block design with a split plot. So each of the blocks would represent the full set of treatments at each site, with one exception. If herbicide is not possible at a particular site, that treatment can be dropped. We just won't have that factor at that site. We'd love to see it happen, but we understand that not all tools are available at all locations. The blocks can be located on different soil types or land use histories at the same types, or even different site prep techniques, as I mentioned. So we've got a lot of flexibility there. The individual treatment plots are on the order of 4 by 2.5 meters, so they're very tractable. We don't envision any walkways between the plots or the treatment units. That way we have less management, we have a smaller block footprint. The space needed at each site for a block, for each individual blocks, is 60 square meters, or that's 8 by 7.5 meters, or 4 by 15 meters if we make it a longer rectangle. We'd love to see replication across the 5 years, summing 100 sites or more. It's strength in numbers. The replication occurs across sites. If we get 20 sites per year for 5 years, we would have a fantastic experiment. And we're beginning this in Oregon, Washington, and British Columbia, but we would like to see RestoreNet be an experiment that is global in application so that we can learn about prairies and grasslands all over the world and how to best improve them everywhere. Costs. We anticipate that if the RestoreNet team were to implement each of these blocks, it would cost $2,800 in supplies, testing, and staff time. And this pie chart breaks that down. You can see there's a cost for plot setup, including seeding and spraying. That's the labor components. Soil testing, seed bank testing, And the soil testing is relatively expensive because there's labor involved in that, as well as a wide battery of soil tests that we are looking at. Seed, the seed itself, we believe will cost around $143 a block. And if we put all that together and measure out all the packets and make that available, then folks can just receive those seeds from us for that cost. Monitoring is $300 or $400 a year for 3 years. And then project management is important for the project because we'll have a lot of outreach back to practitioners and participants to do, data analysis, etc. That actually doesn't cover the costs of all project management, but we need to have a component in there. And then finally, there's data management. We will be receiving and managing quite a lot of data, and we want to do that right. Responsibilities of participants. If you want to be enrolled in RestoreNet, you need to be able to provide access to your site if you want technical support from the RestoreNet team. Provide financial contribution if that technical support is needed. We just can't do it for free. We don't have any funding at all yet, but we are working on that. You need to be able to share all your data about your site and your block, or any data that you collect. That we have to have that, or we won't be able to really do our experiment. And we would ask that you mow the perimeter of your block annually to keep weed seed rain from overwhelming any of our treatment effects. The responsibilities of the RestoreNet group are to allow open participation, share all data with all interested parties. This is an open format experiment. Provide annual data summaries and recommendations, and we will commit to the highest standards of data management and scientific integrity. How to participate. We have developed an online form for you to suggest your site and your level of participation. That form you can link to on our website at appliedeco.org/RestoreNet. And after this webinar, we will share that link with everybody who's participated and gave us their information. This webinar will also be posted. It's being recorded, so that will be available on the website as well. We're hoping that by implementing RestoreNet, we can improve the success rates of prairie and grassland restoration in this region as well as globally. I've given you a lot of information, and at this point I would like to open the floor for folks to provide their feedback. I've given you a summary of RestoreNet and the study design, some information about the costs, how to participate, how to help identify sites for the project, and now it's time for your feedback. So I'm going to see if I can toggle here to make it so that everyone's microphones get turned on. So bear with me. You'll need to unmute yourself if you need to speak. I can hear some background noise. Are there any questions?
This is so is this just for dry air site, or is it also wet needed?
Point of protocol, sorry. If everybody could self-mute and only the speaker unmute themselves, we'll have a better experience.
So I gotta leave the meet.
All right, can
Hi, Tom. This is Kimiora.
okay, thanks. Hi, Kimiora.
Hey there. I was wondering what the timeline might be that you anticipate we could expand this to other regions.
Well, we could do that virtually immediately. We do have some details we'll need to provide on the website regarding protocols for specifics of soil seed testing, soil chemistry testing, that kind of stuff. That some of that could be sent here for analysis, or it could be done independently. The seed mix, we have some discussion yet to have on specifics of how the seed mix will be balanced between species and traits, but we'll get to that very soon, and that will be posted on the website.
Great. I'm thinking, of course, here in the Southwest, there are potentially different challenges for restoration, and I'm wondering if you guys are open yet to looking at different treatments for your site prep and different seed mixes and that sort of thing, or if that's further down the line.
Great question. To come up with an experimental design that's small enough to be sort of done at a large scale, but big enough to cover lots of questions means you've got to cut out some things. So we dropped a number of potential treatments. But we have also discussed the idea of having an enhanced block design that will bring in additional treatments, such as different seed mixes, not the seed rate, but different mixes, balances of grasses to forbs, for example. Also different soil amendment options, such as mycorrhizae or organic matter, things like that. So if you're interested in that potential, if you look at the participation form, there will be a place where you can click a yes or no, I'm interested in that, and also provide verbal feedback.
Great, thank you.
Thank you. Carlo was trying to speak earlier. Carlo, are you still there?
I am still there. I have two questions. One is this only for drier upland prairies or also wet prairies?
Great question. At this point, this is applicable to any grassland or prairie, so upland or wetland. The seed mix, of course, the seed mix will differ if you're into a different habitat, but that's okay.
Okay. And then is this only for prairies where you're starting from ground zero, or also for degraded prairies that you're trying to restore?
Thanks. In general, the idea is this experiment starts whenever the practitioner thinks the site is ready for seeding with natives. In general, that's not the same as a degraded prairie. We had some different experiments a few years ago looking at how to restore semi-degraded prairies. So in this experiment, we're primarily trying to look at kind of bare dirt restoration. But, different people approach this differently, and we're open to different starting conditions. That's one reason why measuring the seed bank is so important.
Okay, thank you.
Yeah, thank you. Any other questions?
Hey, Tom, this is John here.
John.
There's a number of comments in the chat window that you might respond to.
Oh, okay. Yeah, my chat window's not very big here. Let me scan those. Uh-oh. Someone's got a mic on. Sorry about the live mics here. I'm doing mic management right now. Database management system was one of the questions. We have yet to develop our database management system. It's likely that we will use an Access database and have multiple subcomponents for managing the data. We will do data verification as we enter data, and we will do data summaries to detect any errors as well, and also to share the data. I answered Carlo's question. Yes, we would consider different seed mixes. Okay, so we would consider different seed mixes for different areas. So for British Columbia, for example, because of the different provenance, that's absolutely important to do, and we would definitely do that. Another person asked, am I curious about seed source and species? Will seed stock be specific to site and location? Again, we're trying to put together a set of packets for the Willamette Valley as a whole that we could make available to anywhere in the Willamette Valley. We'd like to do something similar for the South Puget Sound. For other areas, we will need to rely on local practitioners to assemble the appropriate seed sources so that they match your provenance appropriately. But we will provide direction on the relative abundance of those kinds of species. Who is the best point of contact if I have possible sites for inclusion? The best way to do that is to use the form on the website at appliedeco.org/RestoreNet. appliedeco.org/RestoreNet. I'll put that on screen here, right there. Go to that website and click on the link for getting involved. How many years, what level of site prep will be required for participation? Site prep, we recognize, is highly variable. It needs to be different in different locations, and different practitioners have different abilities. They're starting from different places. You may be starting from an agricultural field or from a fallow pasture. Very, very different situations. So our experiment starts whenever the practitioner feels they're ready to do seeding. We can make recommendations on that, we're happy to, but that's not a restriction. Another question is, how is the seed bank testing going to be performed? In situ, lab, grow out? We will use a grow out technique where we will take soil samples from the site and spread them across the top of a flat and place them in a greenhouse to see what germinates. Another question is, if a study site is set up on grazing lands, will the plots need to be fenced to exclude grazing livestock? That is a really good question. At this point, the answer is no, but it may depend on the intensity of grazing. If it's just going to be mowed down, then it may be very difficult to see any response, especially from plants that are just at the early stages of establishment. I think we'll have to work with you individually to determine that at this point. Another question, how is the seed bank already got that. Are sites which may be regularly disturbed appropriate for this study? Working on a military base here. Yes, so for example, if you're at Fort Lewis, I think that's fine. We would definitely want to see plots in that kind of context. That's kind of like a grazing site, but different, more of a bombing site and a burning site. Can sites have had some introduction of natives already with only brief site prep? Again, Yes, we are generally thinking of restoration starting from scratch, but that's not how restoration always happens, and we recognize that. So we'll want to know site history. We will have a form when we enroll a site that allows us to capture all this information on site history, where it is right now in the restoration process. Another question was, would there be site maintenance allowed and monitored over time? That's a good question. If we get into the enhanced RestoreNet plot setup, then some treatments may be follow-up maintenance. At this point, we wouldn't want to see any maintenance done that's different across different treatment plots, but perhaps across the entire plot. Is it possible to have someone visit our site in SQUIM to help us consider plot locations, etc.? It is possible. We'd have to talk with our RestoreNet team to see if anybody's going to be up there. So I would say fill out that form and let us know who you are, and we'll see what we can do. If we're private citizens with a chunk of prairie in the South Sound region, will we receive support in terms of preparing the land for participation? It is former pasture. We have no experience in this kind of activity. Fair point, and we would love to engage private landowners, especially those on working lands or on lands they just want to preserve. Right now, we don't have funding to support that, but I'm sure there's some minimal kinds of support we could provide in terms of advice and prescriptions. But we would not be able to come out and do the work ourselves unless you, the landowner, were to provide that funding. And what we've laid out here is for the block, would be $2,800 per block. But we can talk, so please fill out the form. Next question, 10 pounds per acre is on the high side for what we generally do. We'd like to see a less than 10 pound rate, more like 5 pounds per acre and 2 higher rates. And we've gone to putting forbs only in the interior of the site with grass only field borders. Do you plan to have grasses and forbs together in our seed mix? So we've had a lot of discussion over this. This is, you're right on it, Kathy Pendergrass. We went with the kind of the standard base that's what a lot of people use is around 10 pounds per acre. We discussed a half of that and then a double of that, but those experiments that have already been done in our region that have used low seeding rates have had generally low success. And it's those higher seeding rates where things seem to get really interesting and really exciting. They may not be feasible for some people in terms of cost, but they could help us balance our seed mix if we find that some species at a low rate just don't come up, but it takes a higher rate. So consider this an experiment that will produce information that will help you with your seeding rate. The seed mix will be a mix of grasses and forbs. It will not just be one or the other, but that is one of the factors we've discussed putting into the enhanced block for RestoreNet if we go with that direction as well. So thank you for all those questions. I hope I got through all of them. Feel free to chime in if you have any additional questions now. Yeah, I turned on mics just in case anybody wanted to have any additional questions. All right, well, it is 10:45. I'm sure all of you have other things to do with your mornings. We will conclude the webinar now. I thank you all very much for your participation, and this will be posted online as a recording as well. Thanks very much, and we look forward to hearing it from everybody. Have a great day.